Hello all, welcome to Embedded Linux Learning Point, a learning platform for anyone who wants to learn Embedded Linux and Internet of Things. In this series of videos, we are building an IoT platform called Sense and Act. So in the previous video, we have built the toolchain for beagleboneblack, and in this video, we are going to examine the toolchain and see what it contains. To get an idea of what is in a toolchain, let us examine the toolchain we have built and installed for beagleboneblack. The ARM Cortex A8 toolchain is in the directory Home Xtools, ARM Cortex A8 Linux GNEABI BIHF and bin. We can see that it is present in this directory. If we do an ls, we will be able to see all the different compilers that is present. So let us add this to the directory path so that we can use for our development. So we are going to add this toolchain path to the path variable, and we can echo the path and see if it is added. You can see that the toolchain path is added to the path variable. So now that the path variable is updated with the toolchain path, let's take an example of hello world program and execute the build and see if we're able to build this code. The hello world program is present in Sense and Act. Sources, if we do an ls, we have an hello world.c. If I display this with the cat, it looks like this. It's a simple hello world program. So let's build this. So the command is like the GCC compiler or the cross compiler hello world.c and -o with the hello world. So this is the command. Okay, you can see that the program is built, but as you know that this cannot run under this environment because it's not built for x86 architecture. You can see that the hello world cannot execute binary file exe format error. So this is because it's a cross compiled one for the ARM, not for the x86 architecture. So we can confirm that it has been cross-compiled by using the file command. So if you see, when we see file with the hello world, we can see that it's built for ELF 32-bit LSB executable. It's built for ARM EAB i5 version, and it's a dynamically linked interpreter is lib ld linux arm hfs.so.3 for GNU Linux 6.0.2 with the debug info not stripped. So this is the information of the file. So that means it is built for ARM core. So with this we know that our cross compiler is working. To know more about the cross compiler, we can use minus version. GCC -- version. So with that we will know that this is the name of the cross compiler and it is built using the crosstool ng, and the version is 12.2.0. To learn how the cross compiler was configured, we can use -v here. With the -v option, it gives the complete details of how the cross compiler is configured. So some of the interesting parameters or interesting ones is with sysroot. So we can see the sysroot is home frank. Ideally the sysroot in my case is home Virish, xtools ARM Cortex A8 Linux GNEAB high HF ARM Cortex A8, the same, and then the sysroot. So this is the sysroot file, the sysroot folder, and the enable languages is C, C++. Using this we have both C and C++. So also with CPU is a Cortex A8. The code is generated for ARM Cortex A8 core, and with minus float equal to hard, generates opcodes for floating point unit, uses the BFP registers for parameters. Enable threads is a POSIX. This enables a POSIX thread. So these are the default settings for the compiler. We can override most of them on GCC command line. For example, if we want to compile for different CPU, we can override with the configuring with setting like minus with minus CPU, then adding the M CPU to the command line as follows. So let's say if you want to build for the Cortex A5, we can build using the minus CPU option. We will try. So copy this and then paste it. Okay, so then we can also see with the file command, so we can print out the range of architecture specific options available using the target help. So with the target help, we can see that what are all the different options that it provides, that the toolchain provides. Next we will see the sysroot, library and header files. The toolchain sysroot is a directory that contains subdirectories for libraries, headers, files and other configuration files. You can see the toolchain of the default sysroot by using the print sysroot. We can see like that. You see the home Virish, xtools, ARM Cortex A8, Linux. So this is the sysroot file. You can also see in the Explorer where it's installed. You see it's installed in xtools. Here we have something called and sysroot, because this is where all the libraries, bins, user variables and etc. some configuration that exist. It can be set when the toolchain is configured through minus with sysroot, or it can be set command line using the minus sysroot. I think that's fine. By default, we have not passed any parameter to have with sysroot, so it's taking the default directory. We can find the following subdirectories in sysroot. Lib contains the shared objects for the C library, the dynamic linker or loader with LD-Linux. User lib, the static library archive files for the C library and other libraries that may be installed subsequently. User include contains the headers for all the libraries. User bin contains utility programs that run on the target, such as LDD command. The user share, used for localization of internationalization. SBin provides the ldconfig utility used to optimize library loading paths. You can see the library contains different libraries. SBin contains ldconfig SLN, and user bin contains all the tools that we need, like I mentioned, LTD, locally, and other things. The var is a typical variable directory. So other tools in the toolchain. So below is a list of commands to invoke the various other components of a GNU Linux toolchain. So addr line converts program address into file names and numbers by reading the debug symbol tables in an executable file. It is very useful when decoding address printed out in a system crash report. So this is helpful when we are debugging the crash report. So AR is an archive utility used to create static libraries. AS, this is the GNU assembler. C++ filt filt, this used to demangle C++ and Java symbols. CPP, this is the C processor and is used to expand, hash define, hash include, and other similar directives. ELF edit, this is used to update the ELF header of the ELF files. So likewise we have G++, is the C++ compiler. GCC, Gcode, this is a code coverage tool. GDB, this is a GNU debugger. gproof, this is a program for profiling tool. LD is the GNU linker. NM, list symbols from project files. Obj copy, this is used to copy and translate object files. Object dump, this is used to display information from object files. ranlib, this creates or modifies an index in a static library, making the linking stage faster. Read ELF, this displays information about the ELF object format. Size, this lists section sizes, the total size. Strings, this displays a string of printable characters in file. Strip, this is used to strip an object file of debug symbol tables, thus making it smaller. Typically, you would strip all the executable code that is put into target. So these are the different tools that are available for us to use in the toolchain. Thanks for watching.
If this video helped you in learning, please like the video and subscribe to the channel. Also, share with anyone who is interested to learn more about embedded Linux and Internet of Things. Leave a comment below for any feedback or discussion.